Good evening to all of you. Welcome to my channel. Let's see if we can learn about science and what's happening in astronomy and space exploration this week. My name is Alain Faber. I've been teaching science for more than 25 years. Astronomy is one of my interests. So this week we're going to talk about a few topics such as the fact that we're planning the deorbiting of the space station towards Earth for 2030. We're going to talk about Chang-e 6 from China. We'll also talk about the Boeing capsule at the International Space Station. We're going to also talk about the Bennu asteroids and also a few things about the asteroids this week. If it happens that you have any questions, clarification questions, please put them in the comments below. I'm here to answer scientific questions all along. So the first topic is about the NASA and the International Space Station. So when we started to think about the space station, the International Space Station, there you go, and we started to bring into space the first module in 1998, and we ended this whole station by 2010. In 2030, the station will have been in orbit for more than 30 years. Technology is getting older. We have to decide what to do with that object, that space object. And therefore, we're going to talk about it today. And guess who was awarded the project? It was no other than SpaceX. So let's see if I can make this a bit smaller. Perfect. So the whole idea here is that we have a space station that we are looking at. We're looking at its future. There was different options for that. And here we awarded the project to SpaceX. And the project is quite a bit of money. They have awarded a contract with the total potential value of $843 million. Now we have to keep in mind that SpaceX, once they will come up with their solution, make sure it works at the International Space Station, it will not be a recyclable project, because once we are starting the deorbiting of the International Space Station, everything will be disintegrated in the atmosphere. So it's a bit different for SpaceX. But you know what? I don't think anybody else had the technology, the know-how, and the willingness to do so. So the question here that we have is, why did NASA decide that deorbiting the International Space Station for its destruction in the atmosphere the best solution? So here we're going to talk about this white paper. Let's see if I can put it in the comments here, if some of you are looking into following along. If you are looking at this edited version of the video, I'll put all the links in the comments below. Perfect. So let's see. So here there was a white paper, and the title was International Space Station Deorbiting Analysis Summary. Let's see if I can make this a little bit bigger for you. Can we make it a bit better? Perfect. So here we have the International Space Station, keeping in mind that in 1998, when the first module went in, it was in a central part here from where we added all the different modules all along to make and create this space station. So this is an aging piece of equipment. Now, over the last few years, they've been discussing about what were the best way to work on this. So the topic we'll work on it that we'll discuss in a moment will be, is it better? Actually, let's see if we can look at all of those as we go along. One option would have been to have an uncontrolled re-entry. The difficulties with this one is that because of the friction, when the International Space Station goes into the atmosphere, it will burn up. The big issue is that we don't know if everything will be disintegrated in the atmosphere. That means that if there are larger chunks, it could land where humans are, and that would be dangerous. So I think so here they put the odds at 1 to 10,000 likelihood of public risk. That is unacceptable. So that one was set aside. Another option was to disassemble the space station and then return the pieces to Earth. Now, to do that, we need extra resources. We need extra humans, extra people into space. And now, if you keep thinking of disassembly, we don't have the rockets to bring the big pieces back. So that means that you want to break it down in smaller pieces. And how much would it cost? Now, with respect to costs and how much time it would take, it's unlikely that it's possible. keeping in mind that as long as the space station is there, we need to keep people in there to make sure it runs smoothly. The other one was to possibly disassemble the space station and then repurpose some of the parts in the low Earth our orbits. So the LEO means low Earth orbit. Now, if I look, so this is page 3. If I go at the beginning here, so here all the modules are important. Some are taking care of making sure that we have enough air pressure, take care of pollution, carbon dioxide, waste, communication. So if you were to take any one part, how efficient would that be for use in the future? So as a whole, the space station is amazing, but in parts, it would never be able to do what it's intended for. And therefore, that is not, to my knowledge, a great way. Let's see other options. We could decide to disassemble and deorbit into smaller pieces. That's a good option. However, because keeping in mind that the space station was put together as Lego blocks, for example, we could take the small pieces and then send them into orbit. Here, there's a few things. First of all, we need a team to be able to disassemble it. During that time, we need to keep the living space for those humans, making sure the whole thing works and is viable and safe for the astronaut as long as all the pieces are sent back. I think that logistically speaking, I don't think it would work. Another one would be, okay, how about we send we are using booster to put it in higher orbit. Now, one of the reasons why the space station is aging is that it's in low orbit and there's some oxygen molecules still there. So there's some interaction with the station. So that means that we need to repair the station. We need to change parts. We can send from Earth the new parts. We can maintain the station from space. Some parts sometimes we bring back to Earth, we repair, and we send new ones or repaired ones. But that's costing money. The other thing is that the boosters, we have boosters on the space station, enough for it to, because it's always coming closer to Earth. So every couple of years, we are using boosters to bring up the orbit to make sure that there's no deorbiting in the space station to end up in the atmosphere and being destroyed. Now, in order to have the booster to do so, and if you look at here, we have 430,000 kilograms. So it's 430 tons pieces of machinery. It's almost 1 million pounds. So we need new rockets. If you need new rockets, you need to create them on Earth and send them to space. Now, would the space station be able to handle large boosters and the vibration to push it in higher orbit? So that is a good question. And now, keeping in mind that in higher orbit, you also have more satellites, more debris, and then the higher up you go in the atmosphere, the more chances there are to be collisions, and therefore for the lifespan of the station to keep decreasing even more. So I don't think it's a viable option. So here they're mentioning, and also the estimated cost of fuel to be able to maintain it. That's something to keep in mind. There were some graphs to help us. So one option will be to send new propulsion systems. That's also a good one, but we want to take the money, the energy to bring it to space in an aging space station. I know that China has its own space station, and right now we are refocusing our budgets to Gateway, which will be the Moon space station. So here the whole question here is it time to invest in a newer station, knowing that this one is aging? Other option was to decompose or fragmenting the space station. So here, this one of fragmenting. If let's say you were to take the space station and blow it up into smaller pieces for them to come through the atmosphere and disintegrate. The big issue with that is that you would have millions of smaller pieces before they come to Earth when they decide to do so. So in the meantime, it will create a whole bunch of debris in the lower atmosphere and upper atmosphere, causing a whole bunch of different issues for other projects and program we want to have into space. So that is an issue. They also talked about transitioning to a commercial operator. The big issue with this one is that it asked around, but there was no viable projects by a company to do so. Now here you have to keep in mind that in order to have a commercial operator, you are sending a company up into space, giving them access to the technology of the space station, which is okay. However, keeping in mind that the space station is not just an American project, but it also includes Canada, the European Space Station, the Japanese Space Station, and Russia. They all have their own technology that they are protecting in the same way. So here that is an issue. But is there a company that would have the resources to be able to use the space station, but be able to keep on maintaining the space station and all the requirement? And that they haven't been able here to do so. Let's see. There was something where the reasons. So let's see. NASA received no feasible proposal to utilize the hardware beyond the life of the space station of 2030. The reasons are due to age, complexity, and distributed ownership of the station. So here is something here. And the next one here is, should we continue the use of the space station? It's up there. Why not use it again? Now, there's a few things, keeping in mind that it was planned to be used until 2030. Let's see. And if you look here, we're in 2023. In 2030, we have a station that will be whole for about 25 years, but the core part here would already be 32 years in space, plus the time it took to build it. So it's an aging building. Consequence, they decided to deorbit it, and that's what happened, and SpaceX was awarded that contract. So we'll see what all the different research and results and new discoveries will do in the next 6 years or so. But the space station will be landing in the middle of the Pacific Ocean in 2030. That'll be a great event when that happens. Perfect. Very nice. The second news that I want to share with you is Chang-e 6. So that's the second segment. Now, on the 26th of June, Chang-e 6 brought its 2 kilogram, or almost 2 kilogram sample of moon soil back to Earth. So it was 1.935. So it was 1935.3 grams of moon sample. It's a success. Someone was asking, well, it's only 2 kilograms. That's true. But it was all done indirectly because it was on the far side of the moon using technology, satellites, and being able to do it remotely is a success. They have, oops, I should show you the pictures and the title. There we go. We have this one right here. Perfect. So there we go. 1935.3 grams. They have some great pictures here. So here we can see there's a sample going into for the press release and the inauguration. So here we have the plaque. The Chinese must be very proud of their work. Here we have the canister. Can we make this a little bit bigger? We have the canister in which there would be almost 2 kilograms of soil. So here we have the container. Now the question, I'm not quite sure. So if you don't know much about the project, the Chinese in the last several years, they have sent a satellite orbiting the moon to make sure that communication is possible on the far side of the moon. They landed the Chang-e 6. From there was a robotic arm. Here they shoveled some soil and they put it in a capsule above. This upper capsule went up in the sky. So if you remember the old Apollo missions where the American would land here, astronauts on the moon, you had the lower part here. They did their work and then they went back on the upper segment of the capsule, and they will be propelled back into space. So here the structure is very similar here. So the soil samples, there we go, were added here. It was sent back to space, spent a couple days in orbit around the moon, and then came back to Earth. We have also from Scientific American a great picture here when it landed. So we have the capsule right here when it landed on the ground. Now here I have a few questions, because here's the capsule again. And you have the scientists that would have taken the sample. There's another one. So here they open the hatch, and then it was brought up this way. What I'm not sure though is what did they do to minimize the contamination of the soil sample with the atmosphere? So here, this capsule here most likely is vacuum sealed, and I'm sure they did that to avoid contamination with the atmosphere. And we have here how they move it. None of the scientists here have masks, so I'm not quite sure. If you remember the sample from Bennu, and I'll talk about it a bit later, they were very, very careful with that. So here, I don't know if it is a canister for show or if it's the actual sample. That's a good question. But anyway, lunar samples, regardless if it's here or in the lab, that'll be an amazing discovery as we go along. So I'm very proud of the Chinese government for this, and we'll see what else they'll do in the near future. Let's see if we can go to our third news today. Our third news is about the Boeing capsule at the International Space Station. So here I have a great picture here. This dates to June 6th, 2024. So interestingly enough, we have two commercial astronauts that went to the space station. They had a launch that was delayed by a few weeks, if I remember well. Then it went to the station. When they came in from the ground up to the space station, they noticed they had some helium leaks, but it seems that the helium liquid was about 75% left, so enough to return to base. They also had some difficulties with some of the rockets in aligning the capsule to be able to attach itself to the space station. So that was a great success, and I think I talked about it on this channel 2 weeks ago, 3 weeks ago. Now, I was listening to a broadcast not too long ago, and this is a broadcast here. That was yesterday, actually. They were talking about their project, and here they were talking about something specific that was interesting. So they were saying that the astronauts are still at the space station, but they're not stuck at the space station. They're saying that the astronauts are there working with Boeing and NASA and the other people on the space station. And what they are saying is that they are addressing the certification data. So when I was listening to the interview here, they were saying that nobody is stuck there. Just astronauts will be able to come in, but keeping in mind that Boeing needs to have certification to have commercial flight back and forth to the International Space Station. They need to make sure that everything works well. So they're calling it addressing certification data, which is important because the more data you have, the better it is. And we need to make sure that the astronauts, when they are going back in their capsule and back to Earth, they are very, very safe. So that's very good. So they're addressing some thrusters difficulties, some helium content in the capsule. So they're here in the station for about 3 weeks. The big question is, when will they come back? We'll see what happens. I'm concerned a little bit with the well-being of all the people there, because we have extra people on the space station. That means that there's a need for more resources such as oxygen and food and water. There's also more waste and more carbon dioxide. So there's a lot of things that they need to keep in mind. So I hope anyway, that when the capsule leaves the International Space Station, they will quickly come back with new supply for food, oxygen, water, and whatever else they need to make sure that the astronauts on the space station are able to continue their work. So this is excellent. Wishing a great success to Boeing. After SpaceX, I think that's the first private companies to send something or astronauts to the space station. Very proud of them. So let's see what will be my fourth topic today. Okay. My fourth topic today is about the samples from an asteroid called Bennu that was brought back to Earth by Osiris Rex mission. So we have the Chang-e mission 6, the Chang-e 6 mission that brought back lunar soil. Here we have they are giving us some input on what they have found on the different samples. Now here I have also a paper. I'm going to put it in the chat here, and I will put it also in the section here, in the comment section, not the comment section, the description of the video. So if you want to have a look, it would be a very good thing for you to check. So let's see what we've got. So if you look here, let's see if I can make this a little bit bigger. Perfect. So here we have several scientists. So we have the asteroid Bennu with the first properties of some of the samples collected. Now NASA gave a quick paper on the 26th saying that they found some phosphate in some of the samples, and that was interesting because phosphate needs a specific environment often to be created. So let's see what the paper is all about to help us. So I'm going to go down. So here's some information about Bennu. Let's see if I can do this. Okay, I love this because look at this. I can increase the size of these things. Perfect. So we have here Bennu. This is an asteroid that was not too far from Earth. One of the reasons they chose it is that it's a dark color. So it's called a dark asteroids, and the reason is that there's a high content of carbon, and this is raising a lot of questions, and we want to know about organic matter. A carbon-rich asteroids is a great thing. They went to Bennu to get the samples. When the sample came back in September 2023, they started to have a quick look at the samples they received. They had a variety of samples here. Actually, these could have been, okay, let's see, I need the caption. What is the caption of this thing? So here in this boulder called, so here we're talking about boulders. So these are pictures from materials on, there you go. Difficulties this morning. Anyway, from boulders, can we make this? Let's see, where is it? It is right here. So we had from rocks and boulders on the asteroids. It's always interesting because we're always trying to see, looking at shapes, looking at changes of colors, can we get some clues on what's happening right here? Perfect. So here in September 2024, we have here Bennu that came back. So it came back on soil. I remember the geologist came close. That was the geologist at the time. It was exciting. Took some pictures to make sure to document what was there. The key question was, they wanted to make sure that the samples inside was not contaminated from either the re-entry in the atmosphere, so not by heat or by contact to oxygen in our atmosphere, because both would create an issue and contaminate the samples. So here how the scientists here are all protected with masks and everything to minimize contamination of the capsule. So that was not done by the Chinese, but I'm sure they have other ways of taking care of their samples. So here that was the canister when they opened it, and we can see there was a variety of dust and other materials from the asteroid that was gathered, and it just took a ride on the Osiris capsule to come in. So here we had capsules, and I've talked about this project several times on this channel. It's quite exciting. So here different samples taken in different areas of the capsule, keeping in mind that about 75% of this matter is stored to be researched on from decades from now. So here only 25% of the samples is being used and studied on, because keeping in mind that technologies are changing, and therefore new technologies in 30 years will be able to discover more things about this sample. What else? So here are pictures from same samples in the trays. As you can see, they're very dark, very carbon rich, and this is part of what they've been studying. So this one here is interesting. In the part here in the lower part, you can see composition is a bit different, and that got some people excited. Keeping in mind that this is 5 millimeters. So here we have a centimeter, And we have 2, we have maybe 7 by 5 centimeters. That's an amazing piece of rock we can study on. They had some examples, some graphs. I want to show some pictures that were interesting. These are some pictures that came through. And here they mentioned that some of the minerals that on the dust. So here it's the way it's formed. So it means that it needed to have some fluid state environment for the crystals to grow like this. So they're called phyllosilicates. We find those on planet Earth. And from what we know, they need a water-rich environment on for them to grow. And that's raising a lot of questions, and that's exciting for the researchers. So here are other samples. You could see, so these are all magnetite samples. We have little beads. Here, there's a larger beads. Here with, we can see the faces. So laminated here, magnetites. So it's amazing. And at the bottom here, you have pyrrhotite, which is a mineral with iron, some nickel, some sulfur. So here they're starting to study the mineralogy of the samples, which is exciting. Let's see, there's another one I want to show. So there's another one. So in one of the samples they studied, so we have this rock right here. We're zooming in, and here. So this part here is right in this upper part here. And they also found a lot of clay on the asteroids. They talked about smectite, and smectite is interesting because I remember that's often found in sedimentary rocks when there's some heat and this change in chemistry. So that was interesting to see. So lots of clay and phosphate. So that was a big difference because phosphate often needs an ocean-like environment. So if you think of Canada and potash, we have an old, smaller ocean. It all evaporates, and then you end up with phosphates. So that's interesting. And the next one is that we have also carbonate. And carbonate are also created often when there's a fluid-like environment for them to crystallize. So these are a lot of questions for the scientists. And I want to go closer to the conclusions. So the paper is there. It's always interesting. Lots of things I did not understand, but if there are some specific questions, I'd be more than happy to help. Okay, so I want to share with you the idea that they have come up with all these observations. So that means that they have some ideas of what's going on here. Okay, let's see. Oh, I think that's the picture here. So here, that's the sample here, that if they put here with the fluorescence, they noticed that there was some phosphate in it. Very exciting. Okay, so I want to look at their conclusions and insights, discussions. So when they talk about the discussions, they're talking about, about the fact that they're noticing a lot of things, but they're comparing what they see with what they know from Earth's environment. So here they started to do some comparison, and these are hypotheses that they had that they're testing. So that means that they have ideas before they get to the samples, and they're trying to see what can we learn from them. So here they want to test and compare the data from what they saw on Bennu, from the sensors then, and also the chemical content of the sample. So comparisons are important. They're trying to see, are they coming from the same rock type? And the next one here, they're looking with the consistency of the mineralogy. So is it making sense from what we see and what we notice from the sensor up there? There's a few other things. So here they were looking at some samples, and they noticed that there seem to be some materials from outside of the overall chemistry of the asteroids. So here we have materials coming from the outside of the asteroids. There's also resemblance. So that's hypothesis 1.4, resemblance to aqueously altered carbonaceous chondrite. So that means that there's some minerals with carbonate, with magnesium. And what we know is that on Earth, they occur in aqueous solution, so where there's water. So they suspect maybe Bennu is from a larger asteroids that may have had water. That's a good question, but these are all hypotheses we need more data to know what's happening. There were also other things. We are also comparing the samples with what we have here collected from meteorites on Earth, because we have meteorites here that we have found with specific chemistry, and we know that the meteorites have been altered in our atmosphere when they came through. But we can still look at some specific example of chemistry that is interesting. So they're comparing physical properties and eventually chemical properties as well. They also talked about the fact that there's a difference in some of the composition, some of the isotope composition, and that will be part of what we'll learn in the future. Did I understand everything about the paper? No. It makes me think that once you start digging, there's so much more you can learn. So this is quite amazing. So I'm quite happy with that. So much to learn from Bennu, and it's wonderful. So let's see if we can. Oh, yes. The fifth subject today is about the fact that we've had in the last couple weeks, no, the last couple days. So in this week, there's a whole bunch of different asteroids coming our way. So I was looking here from the Jet Propulsion Laboratories. So here they're looking at the next 5 asteroids. So here you have here at the 140 meters, that's for today. Oh, these are all today. We have 61 meter, 21 meter, and we have here comparative areas. So here, if you look at the size here in kilometers, so the distance between the moon and Earth is about 400,000 kilometers. So here it's an asteroid that is much closer than the moon coming our way. I don't know if some of you will be able to see them through a microscope, through a telescope. That's a good question. So the other ones much further, 6 million kilometers. So they're all fairly small. Here 113 meters, and here we have here 3 meters at 5 million kilometers. Why would we care about 3 meters? Well, we've noticed it, we saw it, and that is great. Now these are the ones for the 29th. On the 27th, we had another list, and I remember I was in class this week, and the first one here was about, let's see, I think it was about 240 meters on June 27th, and the second one was 2 kilometers in diameter. And I want to talk about this one a little bit. So here it was called let's see if I can make it bigger. There you go. Can I make it a bit higher so it's easier to see? Nope, that's exciting. So let's do this. So here you could see we have the sun right here, and then we have the orbit of the terrestrial planets. We have Mercury, Venus, and Earth. And you could see that Earth is orbiting this way, and then we had the close encounter of that 2 kilometer wide asteroid getting close here. So here it was 17 times as far away as the moon, so fairly close, especially if it was 2 kilometers in diameter. And you could see here the orbit is not along the plane of the solar system, so it is reoccurring often. I had the list of, let's see, where is that information? I had information earlier about, let's see if I can find it. Nope. So in all of my research this morning, I was looking at the fact that it is coming in 2024. It's coming back, I think, in 2035, but don't quote me on that. And it will be a bit further. So it is here an asteroid that is coming back over and over again and could be close to either Mercury, Venus, Earth, and I think it can be coming close to Mars as well. So it's something that is interesting, and I thought that I wanted to share that with you. Perfect. Very nice, very nice. And I think I have one more piece of information, and I do not have it. So here, I'm just sharing with you, we have eyes on asteroids. If you look here, this is the plane of our solar system. And as you can see, there's a lot of celestial objects here. So we have our little planet. Let's see, where is, so Bennu is right here. So this is Venus. Earth is probably the blue. Earth is right there. So we have here Earth. As you can see, a lot of celestial bodies coming from all angles. And the big question here is to keep an eye on all of them is tricky. And that's why every so often you hear in the news, oh, we just found an asteroid that it would come close to us by so many kilometers or so many millions of kilometers. It's very hard to keep track on everything that is going on there. On this will be the end of our show today. Hopefully you've enjoyed these news about astronomy, space exploration, amazing events this week. It was busy. I loved it. If you have any clarification questions, put them in the comments below. I'm very happy to look at them and answer them indeed. And I'm going to put here another link to one of the, let's see, on Bennu. Is it on Bennu? Good question. When I did the video, I'm going to see if I can put another video related to asteroids. There you go. And I'm going to put it right here. There. I'll see you there in a moment.